Okay, so in this video, we're going to be solving this problem here. We're asked to look at the series. So the series goes from n equals 1 to infinity of n to the fourth times e raised to the negative n to the fifth power. What we want to do is we want to see if this is going to be convergent or divergent. The first thing that I want to do is I want to take the limit. So the limit as n approaches to infinity of this here. So that's n to the fourth times. Now, instead of the negative, I'm going to bring it down because that's good for limits. We don't want the negative exponents when dealing with limits typically. So this is going to be e raised to the n raised to the fifth power. So this is actually going to be 0 because the denominator is getting larger at a faster pace than the numerator, and that's your indication. So that's not good. We can't use that. Then the telescoping series, no. Harmonic series, no. Geometric series, no. Divergence test, we just checked. Integral test, let's see. Let's rewrite this because again, for integration, we also typically don't like negatives unless we are using like the reverse power or something like that. Sometimes we like negatives, but sometimes we don't. So it's up to what we're looking at. But here, if we use a positive, let's say I use u and I set that equal to n to the fifth power, then du will be equal to, well, du by dx will be equal to 5n to the fourth power, which means du will be 5n to the fourth power times dx. We have this, and then e to the u. We can integrate that, yes, so we can use the integral test. So you just have to check, okay, don't jump to conclusions. This looks complicated, doesn't look like it's integrable, so I'm not going to use the integral test. Don't jump to conclusions. Sometimes it looks complicated, but it isn't complicated. It requires you to rewrite it and just think about it. So always for any of these, really just think about how you can manipulate it and how you can figure the answer out using manipulations after manipulations. Okay, so I'm just going to repeat that one more time. It's important. Make sure to manipulate stuff before jumping to conclusions that you can't use a certain test or you can. Manipulations are important. And so that's going to help you to determine if it's convergent or divergent. So integral test. Let's use integral test. Always manipulate. Okay. Try to manipulate and explore your options. So let's see. Let's integrate. So what I'll do is I'm going to integrate this from 1 to infinity, and I'll write it as a limit and go from b approaches infinity, and I'll use x's instead of n's because I like x's. And instead of writing this as like that, I'll just write it like this, and then dx. Okay, so I'll set my u equal to x to the fifth power and du to 4x to the confuse that here, 5x to the fourth power, and then dx. So this is what we will end up with. I'll do this a little quicker than last time. So this is just going to be the limit as b approaches to infinity, and we'll not worry about the bounds of integration. This will just be, so e to the u, and then 1 over e to the u du. Hopefully that made sense. X to the fourth dx. And we forgot the 5, so sorry about that. I have to add a 1/5 outside. 1/5, and then there. That's basically because we have our 5 here, and then 5x to the fourth dx, that's du, and then we have our e to the u because of that, and that's it. So, okay, this thing here, we'll solve that separately. We'll solve that here, okay? Let's just do that separately. 1 over u is e to the negative u du. We can actually use another u sub. You might know how to do this without using u subs or anything, but instead of a u sub, we'll use a v sub because we already have a u used up. You can also use like different variables, but I'll use a v. So v, will set v equal to negative u. So dv is equal to negative 1 du. Negative 1 du. So if we have negative here, we can add in a negative, we can add a negative outside. So this ends up being negative u, negative du, negative 1 du or negative du is dv, and then e to the v. This is just negative e to the v, right? And then plus c, which is negative e to the negative u plus c. That's it. This is what we wanted, really. It's easy, but you know, if you forgot how to do it, there's always this like quick little proof that you can use. So this is the limit as b approaches to infinity of 1/5. So this is it. This is really what you want. And so what I'll do is I'll just take this, I'll put it in a box in 1/5, and that's going to be multiplied by, we have our negative here, and I'll add that in front, and then we have e to the negative u. U is x to the 5th, so it's negative x to the 5th. And that will be evaluated from our 1 to infinity. Okay, so this is also equal to the limit as b approaches to infinity of negative 1 over 5 e to the x to the 5th. I just rewrote this. I brought this down to the denominator. Sorry, it's not infinity. Don't know why I wrote infinity here. This is supposed to be b. Okay, so b1. So this will just be the limit as b approaches to infinity of negative 1 over 5 e. So just plug in b where there's an x, b to the 5th, minus, and then a negative. So I'll just make that positive and not add the negative again. 1 over 5 e. That's it, because it's 1 to the 5th. It doesn't matter. This actually doesn't even matter because whatever we get for the integral is not going to be the actual like the summation. It's just telling you if it's convergent or divergent. So you don't even need to worry about what this is. Unless you're asked, of course, but that's a different story. This over here is going to get you, so this is going infinitely large right here. This whole thing, this is going to get larger and larger. This is going to get larger and larger. This whole thing is going to approach 0 because the denominator is getting larger and larger. So this is 0. Limit as b approaches to infinity. This is 0. Okay. I should, instead of writing it this way, sorry about that. This I'll do separately, and I'll get that to be 0. And then this I'll do separately, and that's just plus 1 over 5e. So this ends up getting 1 over 5e. This is your integral, what you get as you evaluate it. But what this essentially tells you is that this is convergent. It's a convergent improper integral, which also tells you, because of the test, that this is convergent by the integral test. So convergence or divergence, it's convergent. So one more thing that I didn't do, but you should do, is see that this is positive, continuous, and decreasing. This is positive from 1 to infinity. Is this continuous? It is continuous from 1 to infinity. Is it decreasing? It is, because the denominator is getting larger at a faster rate. And so as you go up and up and up and up, the denominator will get larger, but this will get less larger, essentially. And so it'll essentially be, as we get larger and larger, getting to a smaller and smaller and smaller value. So yes, it is decreasing. You can also check that by, graphing it out if you want to see, or using the derivative, or there's different methods you can use. But yeah, what I did essentially is I saw that the denominator is increasing at a faster rate than this. So if we take the limit of this, it's obviously approaching zero, which we did before, which tells you that we're going to, as n gets larger and larger, it's getting smaller and smaller. It's decreasing. That's kind of, you know, one way to think about it. This is getting larger and larger, faster than this. So as we get larger, n goes from something to something else, and then from something else to something else. This will get larger at a faster rate than this, and it'll be decreasing. So PCD was all passed. So we can, of course, prove convergence by the integral test. You should test this before, by the way, and I forgot to do it and I didn't do it. But you don't have to wait till the end, because oftentimes you should obviously check for the conditions before doing the test. So yeah, it's convergent.